Hey guys, I just wanted to go through your absolute value and inverses test review with you. Okay, so let's just dive right in. Number 1, find the inverse of f of x is equal to 3x plus 4. Trick, remember that f of x is really just y. And then how do we start off all inverse problems? Switching x and y. So x is equal to 3y plus 4. Okay, so now we need to solve for y. Pause the video. Try doing this next part on your own. Maybe you just know how to start it off. Okay, you need to solve for y. Pause the video. Try this. Hopefully you're just now unpausing the video. And you're kind of like, oh, okay, Mr. Nolan, I know to get y by itself, I need to subtract by 4. Okay, so I get x minus 4 is equal to, excuse me, is equal to 3y. So when I subtract 4 on both sides, I get x minus 4 is equal to 3y. Now I need to divide everything by 3 because 3y means 3 times y. So to get y by itself, I divide by 3. And this gives me 1/3 x, or you can leave it as x over 3, either is fine, minus 4/3 is equal to y. If you wrote right here minus 4/3, if you wrote minus 1.3, that's okay. I'd accept that. Oh, I forgot my x. But here's your answer, guys. That's how you do it. Okay, pause the video. Try to do number 2 completely on your own. So hopefully you're just now unpausing the video and kind of like, all right, Miss Nolan, I know that f of x is just a fancy y. So I can say y is equal to x over 2 plus 5. And then you thought, okay, I need to switch x and y. That's goal number 1. So I made it x is equal to y over 2 plus 5. And then I subtract 5, so I get x minus 5 is equal to y over 2. And then to get rid of the divide by 2, I multiply everything by 2. So 2 times x becomes 2x minus 10 is equal to y. Something I forgot to write on the last problem that I should have is then at the very, very end, you should change y back to being f raised to the negative 1 of x, which is just the symbol that means inverse. Okay? All right. Let's go on. Let's try to do problem number 3 together. All right. Problem number 3. Graph f of x equals the absolute value of x. Put at least 5 points on your table. Oh, okay. A suggestion, anytime you get a problem that says put 5 points, use very simple points such as negative 2, negative 1, 0, 1, 2. Now you're just going to plug them in. So you plug in x right here, so you get f of x is equal to the absolute value of negative 2. What is the absolute value of negative 2? 2. What is the absolute value of negative 1? 1. What is the absolute value of 0? 0. What is the absolute value of 1? 1. What is the absolute value of 2? 2. So now you can just go and plot all 5 points. So I went left 2 up 2 to do negative 2, 2. And then negative 1, 1 would be left 1 up 1. 0 didn't move at all. And then 1, 1. And then 2, 2. And this is how she looks. Sorry, I'm so bad at graphing. But that's how she looks. Alright, so there's your absolute value of x. It says give the domain and range. Sorry, this guy's about to move a little bit. I don't know how to freeze it on the board. Give the domain and range in interval notation. Okay, so, dang, I was hoping I could select it and move it up. Okay, well, this guy should be all the way up here at 0, going like this. So the domain, we talked about this in class, is all real numbers because it goes to the left forever and to the right forever. So that's the funky R. You all see how this arrow points to the left and this arrow points to the right? So that means it's all real numbers, so it's going to the left and right forever. What was my range? Well, my lowest y value was right here at 0. And remember, range should always be read from lowest y value to highest y value. Okay, my lowest y value was right there at 0 at the origin, comma, and then it never stopped going up, so we put infinity with a parentheses. Alright, let's try number 4. Graph f of x equals absolute value of x minus 2. Oh look, that's going to be the exact same graph we just had, except we're going to move the graph to the right 2. So everything's now going to look something more like this. Everything has just simply shifted to the right 2. So it says, how has it been transformed? Right 2. Alright, let's go on to number 5 here. It says graph. Okay, I'm going to be honest with y'all. I don't really care if you graph or you don't graph it. I mean, I think it'd be wise to graph it, so I'm going to show you. This means reflection, left 1, up 5. So we should go up 5, 1, 2, 3, 4, 5. We should go left 1, and it reflects, so it's going to look something like this, and then it's going to look something like this. Boom. But really, what is the part of this problem that I actually care about you doing? It's the writing out the transformations. So you should write out reflects x-axis, left 1, up 5. Write an equation for the absolute value function described below. The parent function is shifted up 3 units and vertically compressed by a factor of 1/2. So we're going to get y is equal to 1/2 the absolute value of x up 3. What are the coordinates of the vertex? The vertex is just that point where the two lines meet. Usually it's at the origin. Okay, well think about it. Did I move the graph left or right at all? No, so it does not shift the vertex left or right. But I do shift the graph up 3, so the vertex is now at 0, 3. Okay, let's move on to number 7. Okay, I suggest you stop this video and try to do number 7 on your own. It says the parent function is shifted up 5 units, right 2 units, and reflected across the x-axis. So the reflection means, oh, I don't need to put the y equals, they already gave the f of x equals negative absolute value of x. Now how do I say right 2 units? That's correct. Minus 2, close the absolute value, shifted up 5 units, so that's plus 5. So then ask, what are the coordinates of the vertex now? Well, 1, does the reflection actually move the graph left to right or up or down? No, it just makes the graph go from looking like this to looking like this. It doesn't actually move the vertex, okay? But shifting it right 2 and up 5 does move the vertex. So from 0, 0 to now 2, 5. Okay, let's go on. Let's try to do number 8 together. Number 8. Alright, it says write an equation for the following graph. And it shows us an absolute value graph that has been shifted from 0, 0. It's now been shifted all the way over. It's gone to the right 3 and up 1. So they say f of x equals the absolute value of x minus 3 and then up 1. But what about the a value? What about this pesky a value right here? How do I determine that? Well, since it's absolute value, it's actually pretty simple. It will not always be this simple for our future functions, but for this simple, it's pretty easy, okay? You simply look at your vertex, and then you look at your next point, which would be right here, your next easy point, next time where it crosses through, both numbers, all right? And you see that to go up, it took me, the next time I crossed both x and y at the same time, an x and y, like a whole number x and y at the same time, I went up 2 and over 1. Do you guys remember rise over run? Well, absolute value, for linear absolute value, this means it looks like lines. Okay, the a value is basically just rise over run. I went up 2 and over 1. So that means my a value is 2, because 2 over 1 is just 2. So a, which is just equal to rise from the vertex to the run to the next solid point. So 2 over 1, which is just 2. So I put that right there. Okay, so pause and try to do number 9 on your own. I'll give you a hint here. A is very, very easy on this one. Okay, so hopefully you're just unpausing this video. Okay, and it says write an equation for the following graph. And it says f of x equals, and we can tell that I didn't shift left to right at all, but I did go down. Okay, so clearly I went absolute value of x. I did not shift left to right at all, so I close it, minus 1. Let's check the a value. Well, it looks like I went down 1 over 1. So it looks like my a value is just 1. But what do y'all notice about this graph that I haven't accommodated for up here? It reflected, that's right. So I need to put a negative sign right here. Very good. All right. However, a is just 1 because to go from to our next point, we're across x and y at the same time, I went down 1 over 1. So it was 1 over 1, which is just 1. Okay, let's move on. Let's try to do problem 10 together. All right, problem 10 says solve absolute value equation. Be sure to check your, be sure to check your answers for extraneous solutions. Okay, so first, in order to solve absolute value equations, you must get the absolute value by itself first. So I must start off by subtracting 4. So then I get the absolute value of x minus 1 is equal to negative 2. Now that I have the absolute value by itself, now I can set up my two absolute value equations. X minus 1 equals a negative 2, and x minus 1 equals a positive 2. So now I can solve for x. Add 1, so I get x is equal to a negative 1. Over here I add 1, so I get x is equal to 3. So these are my two potential answers that I need to check. So I'm just going to go back to the original situation And I'm actually going to let the calculator do the checking for me. I'm not going to make this harder than it needs to. So I turn it on. This is always the longest part of any video I'll ever have, is watching me foolishly try to... Alright, so math, number, absolute value, x, wait, not x, I'm a dummy. I want to put -1 in for x, -1, close the absolute value, say +4, and if it's right, it's going to give me 2. This gave me 6. And I double checked my work real fast, and it didn't work. -1 did not work. So then that means that -1 is an extraneous solution. Okay? So now what I need to do instead is I need to check 3. Alright? So we're going to do the same thing, but instead of plugging in -1 this time, we're simply going to plug in a 3. And I press enter, and I got 6 again. So wait, did either one of these work? No. They were both extraneous. So there was no solution. No solution. Okay. Alright, I suggest you guys go on to number 11, try to do that one on your own, pause the video, and then pull this video back up. Okay? Okay, so hopefully just unpausing this video, and you're like, Mr. Miller, I got this problem. I know exactly what happened. I'm ready to rock and roll through it, okay? So as to solve the absolute value equation, be sure to check your answers for extraneous solutions. It tells us the absolute value of 2x minus 3 is equal to 8. Look, the absolute value is already by itself, so I can automatically start setting up my two equations. So I can say 2x minus 3 is equal to 8, and I can say 2x minus 3 is equal to -8. So now I can solve for x. Add 3, so I get 2x is equal to 11. Then divide both sides by 2, and I get x is equal to 5.5, or 9/2, whichever one you prefer. So 5.5 or 9/2. So now we're going to go solve over here. Add 3, so we get 2x is equal to -5. Divide both sides by 2, and you get x is equal to -2.5, or -5/2, whichever one you truly prefer. Alright. Did I say 9/2 a second ago? I meant 11/2 if I said 9/2. I apologize. Okay, so you can say 5.5 or you can say 11/2. Those are your options. Okay, so now I got my two answers, and hopefully from number 10 you're like, I clearly need to check them because I did all the work right on number 10, but they were both extraneous solutions. Okay, so I hit math, num, absolute value. Oops. Let's just move this for a second. There we go. 2 times, the first one we're going to check is 5.5 minus 3. And if this works, I'm going to get 8. And I did! So 5.5 is a good answer. So now we're going to check the same thing, but this time we're going to use -2.5. So 2 times -2.5 minus 3. Press enter, and I get 8 again. So they both work. They're both good answers. Neither one of them were extraneous this time. Alright? Okay, go try number 12. See if you can do number 12 without me. Alright, so pause this video and then unpause it after you've finished number 12. Okay, hopefully you're unpausing number 12, and maybe number 12 did trip you up. It is a harder problem. Okay, it really is. Okay? So, solve for the absolute value equation. So, guys, look, here's your absolute value. You have to get this by itself first. Before you do anything else, you must get the absolute value by itself, okay? So that means I need to minus 3. I know you're minusing 3 over to where there's an x. That's okay. So the absolute value of x is equal to 2x minus 3. Now that I have my absolute value by itself, I can set up my two equations. I can say x is equal to 2x minus 3. And then I can say x is equal to, now you have to make a negative version of this entire side. So we say -2x plus 3. Now I need to solve for x in both cases. Most students like to move x's to the left and numbers to the right. That's fine. We can do that. So I'm going to subtract 2x minus 2x. So x minus 2x is -x is equal to a negative 3. So if negative x equals negative 3, I just divide by negative 1 to get x positive, and I get x is equal to 3. And then over here, I would have to add 2x, So then I get 3x is equal to 3, divide by 3, and I get x is equal to 1. So I have two answers for x, 1 and 3. So now I must check to see if either one of those is extraneous. So we start off by plugging in. So we say math. And now really guys, if you know what absolute value does, plugging it into the absolute value is useless because you should be able to like, oh yeah, the absolute value of 3 is 3. But I'll go ahead and do it anyway just for the sake because I've been doing it. So absolute value of 3 plus 3 is 6. So now I need to check the other side, plugging in 3 for x and see if they equal. 6 equals 6. Good! X equals 3 is a good answer. Because when I plugged in for both x's, the left equal side and the right side of the equal sign both work. Alright, let's try this other one. This time, instead of plugging in a 3, I'm going to plug in a 1. So the absolute value of 1 plus 3, and that gives me 4. Now hopefully you can already look at the future and see that this isn't going to work. But when you plug in a 1 for the other x, you get 2 times 1, which is 2. And these don't work. So this x equals 1 does not work. It is extraneous. Alright. Whew. I know this video is getting long, but I'm trying to take my time here. So go ahead and try to do all 4 of these without me. Hopefully you're now unpausing, and hopefully you were able just to fly through all those, because those should just be practice. Alright, the first A says f plus g of x. That just means add the f function, 2x minus 5, to the g function, x plus 3. So then I can just literally add like terms. Adding functions is super simple. 2x plus x is 3x. Negative 5 plus 3 is negative 2. So you get 3x minus 2, and boom, that's our answer. It's literally just that simple. Alright, what about f minus g of x? Well, now this one's a little bit harder. So you get to say 2x minus 5 minus the g function. But the minus sign goes to the entire g function. So that's why you guys will always see me put the g function in parentheses to remind myself that when I drop these parentheses, this negative sign goes to both things in the parentheses. So I get 2x minus 5. Let me write it down here. So I get 2x minus 5 minus x minus 3. Now, I put like terms together. 2x minus x is x. And then negative 5 minus 3 is negative 8. So you get x minus 8. Okay. Maybe that's as far as you got. If you did not do C or D yet, take a moment and try to do C and D. Okay, problem C says f of x times g of x. Here's f of x, 2x minus 5. So now, since I'm multiplying two functions together, it is imperative you put both in parentheses. So 2x minus 5 times x plus 3. So when you're multiplying parentheses, it's best just remember that everything from the first parentheses needs to multiply to each individual thing in the second parentheses. So it means this 2x needs to multiply to both of these things. This negative 5 needs to multiply to both these things. So 2x times x, I'm just going to write my answer up here. That gives me 2x squared. 2x times 3, that gives me plus 6x, so I make sure to write my plus sign. Negative 5 times x, I write minus 5x because it's going to be negative. Negative 5 times 3, I write minus 15. Now I just put like terms together. After you multiplied everything, that's your next step. Put like terms together. So I get to write 2x squared minus x minus 15. And I'm done. That's it. That's all you had to do for this problem. Alright, last but not least is D. D stands f composed of g of x. Okay guys, this is a composition problem. That means you need to take the g of x function and put it in to f. Okay? So here's your g of x function, x plus 3. It needs to go into the x spot on the f function. So 2 times x plus 3 minus 5. So we multiply across. So we get 2x plus 6 minus 5. So then we just put like terms together, which gives us 2x plus 1. And bam, f of g of x is just 2x plus 1. Whew. Alright guys, I know this is a long video, but please Please do not hesitate to send me an email with questions, send me a remind with questions, to stop by in the morning at 8:30 to 9 with any questions, okay? I want you to do well on this test, so hit me up with questions. Remember, learning is your job in my classroom, okay? All I can do is present the information. You have to really take control of it. So please let me know what questions you have. I want to answer them, okay? I hope you guys have a wonderful day. Please let me know what questions you have. Thanks.